Hello and welcome to the Stardog Academy training on Advanced RDF and SPARQL. This is Joseph Hayes, one of the senior software engineers at Stardog. To let you know a little bit more about me, I love helping customers maximize the value they can get from their data by implementing innovative solutions to complex data problems. Today, I'm going to walk through various advanced Stardog functionality. In this training session, you will learn how to use paths queries to discover the many ways two nodes in your graph can be connected. Use full text search with Stardog data. Discover where your data comes from using Studio's Provenance feature. Explore your spatial data using Stardog's Geospatial support. Centrally manage your queries using the Stored Query Service, or SQS. Write flexible queries using name graph aliases. Bridge the gap between property graphs and a knowledge graph by leveraging edge properties, an RDF SPARQL star expansion. By the end of this training, you will know how to use several advanced Stardog features. Let's get started. This section is about path queries. Path queries find paths between two nodes in a graph. They are similar to SPARQL property paths. But unlike SPARQL property paths, which return only the start and end nodes, Stardog path queries return all the intermediate nodes as well. In addition, Stardog path queries allow arbitrary SPARQL patterns to be used in the query. By default, path queries return the shortest path between two nodes, but can be used to also find all paths between two nodes. Paths can either be simple, a path edge is a graph edge, or complex, a path edge is actually a subgraph. You can also use path queries to find simple cycle paths, where the start node is equal to the end node. Using the sample music database, we can find all the items where Paul McCartney is the producer by running this simple paths query. We can also query complex paths, cyclic paths, and even all paths between nodes. Please note that using paths all can return a very large number of queries. Use them only when necessary. This concludes the section on path queries. This demo is for path queries. We can use path queries to discover the links between a starting and an ending node. In this example, we're going to discover all the nodes connected to Paul McCartney via the producer predicate. We can also use complex paths in our paths queries. In this one, we're not only looking for people connected to Paul McCartney via the producer predicate, but also its inverse. Notice the number of results has gone up dramatically. We can also use paths queries to help us find simple cycle dependencies, where the starting node is the same as the ending node. So in this life sciences R&D graph, if I want to verify that no starting node is connected to itself via the influences predicate, I can run a cyclic query. Finally, we can also use the pass all keyword to discover all the paths between a given start and end node. In this case, I'm going to find all the paths that connect John Lennon to David Bowie via the writer predicate and its inverse. Please note that paths all can return a substantial number of results. Hence, my use of the limit keyword to limit our results. Finally, with path queries, you can use reasoning as well. like with any other query, simply toggle the reasoning, toggle on, and then run the query. This concludes the demo on path queries. This section is on full text search. You can enable full text search on any Stardog database. This will create a search document for each RDF literal. Search-enabled databases provide a special predicate for use in simple queries. A service search form is also provided for queries with multiple input constants and output variables. Search results can be highlighted. You can also extend Stardog's native full-text capabilities by creating a custom analyzer. In order to search-enable your database, make sure to set the database option search.enabled equals to true when creating your database. Stardog provides a text match predicate for use in a simple query, which we see in the screenshot on the left. It also provides a service form of search, which we see in the screenshot on the right. Stardog's search capabilities can use a variable bound in the same scope or provided externally as input. In the example query on the right, we see that the genre variable is used as our query with the service form of search. You can also have Stardog return results with search hits highlighted. This could be for use in a web application or web page displaying the search results. This concludes the section on full text search. This demo is for full text search. In this example, we're using the text match predicate in order to perform a full text search on our database. What we will do is we will search the titles returned by the previous line and return the score for each title. Notice we return the movie, the title, and the score. Stardog also offers a service form of the full text search. In this example, we're gathering all of the movies and their genres. We're then feeding that genre to the text match service, and we're getting back the related genre and the score. We will then use that related genre to further filter and find related movies. Now, notice I can also use some additional keywords here. If I want to do the limit on the number of search results, an offset of where I want to start looking at the search results, or a threshold, a certain score I want returned. Finally, I can also ask for the search results to be highlighted, which I can then go and use maybe within a web application. This concludes the demo for the full text search. This section is about provenance. Provenance allows you to explore where your data comes from, which databases, virtual graphs, are the source for different classes and properties. Here we see a screenshot of the provenance feature of Stardog Studio. We are showing where the different concepts or properties and classes come from, whether they belong to the native Stardog database or from a virtual graph. This concludes the section on provenance. This demo is for provenance. Provenance is a feature where we could tell what is the source of our data. When I select a database, Stardog tells me where the various concepts within my graph are coming from. In this example, the engineer concept comes from the native Stardog database. But these concepts all come from the DVD rental virtual database. And these concepts come from the GeoNames virtual database. So there's a way of establishing where your data comes from. This concludes the demo for Provenance. This section is on Geospatial Queries. You can enable Geospatial on any Stardog database with geospatial data. The data must be encoded using WGS84 or the OGC's GeoSPARQL vocabulary. In order to enable Geospatial on a Stardog database, please set the database option spatial.enabled equals true when creating your database. In addition, Stardog provides support for several operators, including relate, distance, within, nearby, and area. In addition, data types are defined by the QUDT ontology and the OGC units vocabulary. In the example, in the screenshot on the right, we query for all the points within 2 kilometers of Buckingham Palace. This is an example of the geo::nearby function. This concludes the section on geospatial queries. This demo is for geospatial queries. In this example, we're illustrating the use of the nearby function. In our subquery, we are returning the latitude and longitude of Buckingham Palace. We're then using that longitude and latitude to drive the outer query, which is pulling out all features that are not Buckingham Palace and are within 2 kilometers of Buckingham Palace. And as you can see, we get a number of results. We could also change this if we wanted to, lessen it somewhat and get things even closer to the palace. And there are other units available within the QUDT vocabulary. This concludes the demo for geospatial queries. This section is about the Stored Query Service, or SQS. Stardog supports a way to invoke stored queries, including path queries, in the context of another SPARQL query. Stored queries can be invoked via the SPARQL service keyword. You can choose which stored query variables can be used in the calling query scope. You can alias the stored query variable names to another name. You can statically bind stored query variables. In addition, you can use the service to call path queries. Stardog also provides some special functions to perform operations on those return paths. These include length, nodes, any, and all. The functions any and all allow a user to check if a condition holds for some edges of the path or all edges of the path, respectively. In the following example, we invoke the stored query movie ratings to get us back all of the movies with a genre equal to drama. We then use those results to also return a movie's title and its director. This concludes the section on the Stored Query Service, or SQS. This is the demo for the Stored Query Service, or SQS. In this example, I'm going to show the usage of the stored query service. I start with a stored query called movie ratings. Movie ratings returns a movie, its genre, and its ratings. And I've ordered it by genre and then rating in descending order. I'm then going to use that in another query. So you see the use of the service keyword, and I call my stored query by prefixing its name with query : / /. I then statically bind the genre variable to drama, and I get back all the movies with drama and their ratings. In my outer query, I'm then also getting the movie's title and optionally its director. I'm limiting the results to 10, and again, I'm ordering by rating in descending fashion. If I run my query, I get back the top 10 drama movies. This concludes the demo for Stored Query Service, or SQS. This section is on named graph aliases. Stardog allows a user to create an alias to refer to a named graph. Why would you want to do this? Well, think of a common data cleansing scenario. We import data into a named graph and process it for use. When we want to promote this data to a different environment, say staging or production, we can use a named graph alias to refer to the data. This way, queries can be written to simply interact with the staging or production graphs and not worry about the underlying data. Aliases can point to any named graph, local or virtual. Queries written using those aliases do not need to change even though the alias is updated. They can be used in both read and update queries via the from or the from named and using or the using named keywords. Stardog named graph aliases honor named graph security. Please note, they cannot be used with graph keywords, construct, insert, or update templates, or add, drop, clear, copy, or move queries. Nor can you use an alias to point to another named graph alias. In order to enable named graph aliases, please set the database option graph.aliases equal to true. Let's look at an example. We can create an alias for a named graph and then use it in queries. When you need to, simply repoint the alias at another named graph and continue to use it in your queries. The alias will now refer to the new dataset. This concludes the section on named graph queries. This demo is for named graph aliases. We can create a name graph alias by inserting a triple into the tag : Stardog : API : graph : aliases named graph. In this example, I'm creating an alias for the example : movies named graph called example : best movies. Just to show you, I currently have data within the example : movies, but if I try to query, example : best movies right now, I get back nothing. So now let me create an alias. I create the alias. I then show Nothing's changed. I can still get to the data via example:movies, but now I can also use example:best movies. And if I need to move this tag or alias another graph with the same name, I'm simply updating the triple in that special named graph for aliases. This concludes the demo on named graph aliases. This section is on edge properties. Edge properties allow users to attach information to RDF statements by using them as the subject of another RDF statement. Edge properties are based on an RDF SPARQL extension. Edge properties also bridge the gap between RDF data models and property graph data models. When you want to use edge properties in your Stardog database, please set the property edge.properties = true when creating your database. Let's look at some examples. Stardog supports the RDF SPARQL proposed syntax of setting off the edge with double angle brackets. You can even bind the variable to an edge. Notice the use of the double angle brackets in the screenshot on the left, where we set off the statement, find me all employees who are engineers, and find me all employees who work at Stardog. To the first statement, we attach the property since year. To the second statement, we attach the property source. In the other screenshot, we are binding the edge property to the statement employee and engineer. We then use this bound variable edge to issue an edge property query. Find me all edges until year. Note that if the embedded edge or the statement within the double angle brackets did not exist in the graph, it will be added when edge properties are added to the graph, similar to how it works in property graphs. Some RDF vendors do not require that the embedded edge exist in the graph. That is, it can only be used as a complete statement as part of the edge property queries. In addition, Stardog supports a syntax where you can add the properties next to the predicates of the statements, enabling a query writer to take advantage of turtle-style shortcuts. With the RDF SPARQL syntax, you cannot use any turtle shortcuts in the double angle patterns. Please note in the screenshot the use of the turtle shortcut semicolon, to say that the same subject will be used for both predicates. This concludes the section on edge properties. This demo is for edge properties. With the implementation of the RDF and SPARQL proposal for edge properties, Stardog has the ability to use an RDF statement as a subject in another RDF statement. So in this example, I'm finding all engineers and then asking for the year since they've joined the company. I'm also asking for all employees who work at Stardog and the source of that information. So if I run it, you see I get back employee, year, and who. Now, I can also bind that statement that I want to use as a variable and then use it in additional statements. So, engineer is bound as the variable edge, and then following edge until year. Now, the double angle brackets is the actual proposal from the W3C on the syntax to use. Stardog has also introduced its own syntax where you can add the properties next to the predicates of the statements. And this enables you to take advantage of all the turtle shortcuts we know and love. So here our statement is person A engineer, and we want to pull back the edge properties since and until, and then we're also going to use that same subject again and follow the works at predicate and also pull back the source edge property. So there we go. We pull back Pete, who's an engineer since 2010. He was an engineer until 2018. The source of the information is HR, and the organization is Stardog. This concludes the demo for edge properties. That concludes the Stardog Academy training on Advanced RDF and SPARQL, where we reviewed how to use paths queries to discover the many ways two nodes in your graph can be connected. Use full-text search with Stardog data. Discover where your data comes from using Studio's Provenance feature. Explore your spatial data using Stardog's Geospatial support. Centrally manage your query using the stored query service. Write flexible queries using named graph aliases. Bridge the gap between property graphs and a knowledge graph by leveraging edge properties, an RDF SPARQL star extension. Thanks for following along. If you have any questions, please review our frequently asked questions page or head to stardog.com/docs for additional information.